Hi there, I'm Jacob. Today me and my colleague Nick is going to present on the topic binary numbers and hexadecimal numbers. So let's start with binary numbers. It's a number system where a number is expressed in the base 2 numeral system, which uses only two digits, typically zeros and ones. An example of a binary number would be something like this, 110100. It is used by almost all modern computers and computer-based systems. Each binary digit is known as bit, and all binary numbers are saved in the form of 8 bits, called a byte. So how do we go about converting a binary number into an arbitrary number? Well, the arbitrary number is equal to the sum of binary digits times the power of 2, expressed as 2 raised to n. Let's take an example. So we have 10010. So for each of the digits in the above binary number, we represent them in the power of 2. But we start from the reverse order. It means for this 0, we have 2 raised to 0, and for this 1, we have 2 raised to 1. For this 0, we have 2 raised to 2, then we have 2 raised to 3, and finally we have 2 raised to 4. So what do we do? Well, all we have to do is just multiply this power of 2 position with the corresponding binary digit. So we have 1 into 2 raised to 4 plus 0 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. And when you calculate, you get 16 plus 0 plus 0 plus 2 plus 0. The final answer is 18, which means this binary number, that is 10010, when converted into the arbitrary number, you get a number of 18. Now, Nick will explain more about hexadecimal numbers.
The hexadecimal system is essentially a means of simplifying binary or shortening it, making it more manageable for us humans to understand. It's a base 16 system which uses numbers 0 to 9 and letters A to F, as you can see in the table I have on the screen here. This is what a hexadecimal might look like. As you can see, it uses the prefix 0x to tell the reader that it is indeed a hexadecimal. So what I have here on my screen is a bunch of random binary, which I've converted to hexes down below. The key takeaway here is that the information density is much greater in hexadecimals, which is ultimately one of the reasons why we use it. So how do we convert from binary to hexadecimals? So starting with a simple nibble of information in the first line here, we can see that 1100 in binary represents the number 12. So we look at what hex represents 12 in our table, and we find that it's the letter C. So our final hexadecimal is simply 0xC. As we encounter larger binary numbers, we simply break them down into nibbles and obtain the corresponding hex using our table. So hopefully you begin to see here why we use hexadecimals and how it's easier for us to read, write, and comprehend. And that concludes our presentation. Hope it wasn't too rushed, and thank you for listening.